Yeah.
So I got, so is it -2 for the degree
Yeah.
of freedom then?
Yeah.
Oh, okay.
All right. 1, 2, 3.
What? Join our group?
Yes.
Oh, I'm sorry.
3.
Oh, that's us?
Yeah, it's us. And I, you either.
Oh, dude, right.
You mean I'll do this?
And he's fine with
Not
that.
exact.
I mean, Haley, he's probably just only one video.
Yeah.
I would do like a
Wait,
third video. That's 3 hours.
you got it. I got it.
Talk loud enough to get me.
First off, we gotta find our h of O and h of A, which are rho equals 0 and rho equals, or does not equal, sorry, 0. And then what's called, just to make sure we know what's going on, you can make a bell graph.
We can then plug our R into the formula.
Which theoretically we could have found out by putting the numbers into the data sets. Then we found those numbers by taking the alpha onto the t-chart. And what's good, after plugging that into the formula, it equals 6.366.
And then we reject the null because it's way outside of the bell. And then the correlation coefficient is significant.
Made that like one flowing sentence because we said we reject the null and notify or notice that the
Or
correlation.
you just say accept that the correlation coefficient
Oh,
is
okay.
significant.
Yeah.
Technically, we're proving that it's a positive correlation, right? And it's a significant positive correlation. But if the sentence is written like that, is it significant? You answer their question. Yes, it's significant. You don't have to add extra information by saying it's positive, or anything like that. You just say, yes, significant. All right? Which means that there is a relationship between the home games attendance and the salaries of the players.
Gee, you guys are funky
What? Funky what?
sixes. Looks like the
I like your 6s.
.366
They're cool.
looks like pretty low. They're just pointy.
Low. Hello. All right. So let's read this through really quick. This is that, I believe, was it Ryan asked correlation versus causation, like just 2 days late on the MCAs? Okay, so if you're thinking about whether something is correlated or caused, you need to think about these questions. 1, is there a direct cause and effect relationship between the variables? That is, does X cause Y? For example, the gross domestic products and the carbon dioxide emissions that we just talked about. It's kind of expected, right? The more you produce with factories, probably the more CO2. So basically, is it reasonable? Second one, is there a reverse cause and effect relationships? They had Old Faithful data that was in this section. Basically, they were talking about like how long you know what Old Faithful is?
The geyser.
It's a geyser in Yellowstone, right? And it's pretty regular, but occasionally it'll go for like a little longer than usual, like it'll erupt for a little longer than usual. And when it erupts for a little longer, then it's a little bit longer between the things. So basically, as the force goes up, so wait a minute. I think it's the duration. I must be wrong. I was thinking that the duration changes it.
Like height?
Maybe it's height.
Can you just like switch which variable stands for which one and it becomes a normal cause and effect again?
What?
Can you just like switch which variable stands for which one and it becomes a normal cause and effect again. I say I now need my y at x and my x and y, so I switch them. Would
Uh-huh.
it become a normal cause and effect again? Or am I thinking about a reverse cause? Okay, never mind, just keep on explaining, I'll understand it probably.
Okay, I'm confused about what you're saying.
It's probably just height distance and like wait time in between.
So it was the duration of the eruption and the time until the next eruption tends to increase. Okay, I was right with what I was talking about. But they were talking about, because that's a positive linear correlation. I think they were saying, not that time, okay, so it was the duration, so how long it is, and then the time until the next eruption is also long. They had one that was reverse.
On the same thing.
Yeah, I'm just trying to think of a way to change the sentence to make it reverse. So,
Just the shorter the shorter.
yeah, but the shorter, but I'm talking about like change the word duration or something to something else, like how long each eruption is. Well, whatever, we can think of something else. Let's think of something, how much money you've spent and how much money you still have. Right? One goes up, one goes down. Possible to conclude that the duration of eruption affects the time before the next eruption. They do have a positive linear correlation. Oh, I see. The reverse cause and effect isn't so much the up and down. The reverse cause and effect is saying that, like, even though it seems like one might cause the other, it might be the afterwards that caused the before. So when something, if you're looking at the duration first, the time between, then you should have considered how long the last eruption was, kind of thing. So it could be that you're switching the two, one causes the other. Like, for example, when we're talking about baseball, we're talking about home game attendance, right? And then player salaries, which causes which? Like, we can say that they're probably causal. The question is which causes which. Do more people attend because we pay our players better and therefore we have better players and therefore people want to come to our games? Or are we making so much money on attendance that we can afford to, pay our players better? So you don't really know which one is, so it could be that as reverse causing an effect. Next one.
So if you switch x with y though.
That's what you're saying.
Yeah.
Okay.
That's normal cause and effect.
Yes.
Okay.
Is it possible that the relationship, that's what you're asking, my bad. Is it possible that the relationship between the variables is